Greetings class, welcome back to the classroom. As always, I'm Professor Leo and today we are tackling the invisible superpower of modern software development, the Version Control System, or VCS for short. More specifically, the one and only Git. Now imagine this scenario. You're working on the greatest final project of your life, let's call it Project Awesome, and you decide to make a big change. You hit save. Then, disaster strikes. The whole thing breaks. What do you do? Panic? Yeah, that's one way to handle it, but no. You time travel to a point where your project still works. Git commands are here to save your time throughout your development workflow. Git is essentially a toolkit for common tasks like managing your code changes, handling branch management, and reviewing history. It's how professional teams keep track of everything. Before we start traveling through time, we need the time machine. Unlike some other programs, Git doesn't usually come pre-installed with your operating system. So, the first step is getting your Git installed on your computer. This may change depending on your operating system. In the case of Windows, you need to go to the Git website and download the installer. But for systems like Linux, Git is most likely in your package manager. For example, in Ubuntu or in Debian, all you need to do is sudo apt-get install git and it will find the installer. If your version of Ubuntu and Debian is one of the latest ones, of course, because really old versions of the system might not have it in the package manager. With that out of the way, let me try to install in Windows, since it's the one I'm using at the moment. So I just need to go to Git, click on the first link that appears. Be careful for scam websites, some might appear. Always check that it's git-scm.com. And then we press download for Windows. Click here to download the latest Git for Windows. That's correct. Save. And then, once it's downloaded, we just open it. And it will start installing. Hit next, next, hit next. This could just hit next several times, unless you want to decide any custom options for Git. But usually the default options work really well, so nothing to worry there. Okay, and with that, Git is now installed. So, now that we have Git installed, let's move on to the next part. Let me create a folder on my desktop, which I'm going to call Git project, for example. Okay, we have this folder created, and if I right-click, I should have Git bash here. In the case of any other system, you'd mostly want to cd into the folder via terminal, or you'd want to, for example, open the folder in terminal. Since Windows operates in a different way, it's open git bash here. You can also open in terminal in other Windows installations like Windows 11, or a very customized Windows 10 install, but in this case, it's the bare minimum. So yeah. Okay, now that we have this done, there are two options that we can do. We can start fresh, or we can clone. I'm going to start fresh, and after that, I'm going to explain how to clone a project. So, to start fresh, all we need to do is be in our folder in the terminal and say git init. This basically creates an empty Git repository and creates the hidden folder that's .git. If I go here and say view hidden items, here it is. there's the .git folder. This folder is basically a folder that stores all your configuration and logs for your repository itself. And yeah, basically you have your Git repository created. This will track everything that happens inside of this main folder. So, for example, if I create test.txt, it will detect that a file was added later on. I'll explain it when we get there. So yeah, by default, Git creates the main branch as master. So do be careful with this, because some systems may use main as the main branch and not master. This can be changed, and I'll explain it later on. Okay, with option A done, we now move to option B, which is to clone a project. Say, for example, your project already exists in the cloud somewhere, be it GitHub, Git, GitLab. You can clone it. And to basically do that, all you need to do is basically go to the repository you want. So for example, let me go on GitHub and copy one of my own repositories that are publicly available. Let me see. Let's go grab the Unity toolbox, for example. I'm going to go here, and where it says code, I'm going to basically press it and press the copy URL to clipboard. Now, if I cd to the upper directory and do git clone and then the URL I copied, it will essentially make a copy on my system of the whole project. In some cases, you may need to configure the authentication credentials for the specific repository if the repository is private or part of an organization. That can be explained in a later video, going more in depth on the other aspects of Git, GitHub, and everything else. Now, let's talk about the absolute most important daily workflow, saving your changes. This process involves 3 steps. First, you check your status. Before you save, you need to know what you've changed. So, by doing git status, it will show you the status of your working directory and all of the staged files. So, when you add, change, or delete files, Git can show you the differences. For example, if I do git status, hold up, apologies, I was in the wrong directory. Okay, git status. It will say untracked files test.txt and then says use git add the file name to include it in what will be committed. So that's the next step, which is the staging area. Git doesn't automatically save every change you do. You have to tell it which changes are ready for the permanent record. We use git add to move files to the staging area. Think of staging as polishing your essay before handing it in. You can stage one file with git add and the file path, or if you want to stage everything recursively from the working directory, you can use git add and then a period after the add. And basically that's it. So, for example, if I do git add and now git status, changes to be committed, new file, test.txt. It went, it saw that test.txt had been added and was basically untracked and added it as a staged item. Once the changes are staged, we create a commit. A commit is your snapshot in time. It's a permanent record of the state of your code. You always include a message explaining what you did. For example, git commit -m for message, and between quotes I say added a test file, and for example something else. Okay, it will also say that my identity is unknown. So first I need to configure my identity. For that, we do the commands that are shown on the screen. User.email, let's say it's my email, and git config -- global user.name, let's say like so. Okay, now if I go grab the message, there it is. Oh wait, but I made a typo in my commit message. How do I fix it? Okay, let me fix it real fast by doing git commit --amend -m for message again, and say added a test file without the 31 at the end. There's another way to do this, which is without the -m at the end. This basically opens a text editor. So if I do QA, oops. Okay, in this case I need to close because I'm not familiar with the specific one that Git Bash uses, so yeah, no worries about that. But in essence, we've committed our changes into the repository, and all we need to do now is basically share our changes. Okay, now that we are ready to share our changes, all we need to do is first tell which remote repository we need to point to from our current directory, because this is an initialized Git folder. By default, if you clone a repository from the internet, it will point the remote to the basically the place where you cloned the project itself. In my case, it's different because the remote is empty at the moment. So, in my case, I already created a repository in GitHub because my OBS kind of crashed while I was recording this part, but it's simple to redo it. Basically, you press this plus button here and say new repository, and basically fill in the repository name, description, configurations, etc., and just create repository, and it will show like this. Now, we can basically just follow the command that is listed down here. Push an existing repository from the command line. Nowadays, most code hosting platforms already show up this command, so it makes it easier for you to do it. So I'm going to do git remote add origin and point it to my repository. And now I can both pull and push my changes to the repository itself. Okay, now for the part where Git feels like time travel. It allows us to manage separate lines of development, named branches, and review every step of our journey. You can switch to a specific branch using git checkout and then the branch name, or you can create a brand new branch and instantly switch to it by running git checkout -b and your branch name. In this case, I'm going to do it for the main branch. Git checkout -b main. And there we go. We switch to the main branch. If I do git status, on branch main, nothing to commit. And basically that's it. We switch to the main branch. Now I can basically push my changes into the origin repository. In this case, the GitHub project. By doing git push -u origin main. -u basically says upstream branch is origin main. So points my current branch to the origin main branch, which is the GitHub repository's main branch. So if I do this, say yes. Okay, in this case, I need permissions, but it would basically show you a progress bar for the push. And in the case of someone else doing changes to your branch, you could just do git pull, and it would pull the current changes in the branch itself. In this case, I need to set a public key, which we can do in a separate video. But yeah, besides that, you have a multitude of other commands that you can run to basically review your history. For example, git log. Git log basically shows you the commit message history. Say, for example, let me do git branch -b development, switch to it, git checkout, never mind, silly me, git checkout -b, and let's say, for example, I'm going to create another file, dev-test, and basically commit it, commit-m, added a dev test file. Okay. Let me go into the git log, and now you have the new commit message on top. Now we can do a really funny thing. Let me check out back to main and do git diff to development. Deleted file mode, index. Okay, it shows a change, which is the dev_test.txt. In my case, on the local branch that I'm on, that file doesn't exist, so it appears as deleted file. But if I want to do git merge development, updating, fast forward, and it says one file change, 0 insertions, 0 deletions. And now if I do git log, it's also on this branch. Basically, git merge allows you to merge the branch you want that has new changes into your current one. Sometimes there may appear some git conflicts, but those can be resolved mostly immediately. So yeah, that's basically how we manage our history in Git. So there you have it, the absolute basics of commanding Git. You now know how to install the tool, start the project, save your progress, and share your work. So you can basically develop with other people in your project. Or, if it's an open source project, basically with anyone that's participating in it. Remember, Git commands are designed to save you time. Practice these basic commands and soon version control will feel like second nature. That's all for today, class. If you enjoyed, don't forget to like, subscribe, and comment down your feedback and what else you want to learn. I'll see you all in the next class.